So let's talk about little warm-ups. On the warm-ups today, the first two are review from Algebra 1. Okay, so it's distributing and then combining like terms. So if we look at number 1, let's see, let's put it on that and that color. So we would distribute the 2, and we would get 2x plus 6. We distribute the negative 5, and we get negative 5x plus 5. And then when we add our like terms, if this will maintain connection, there we go. When we add like terms, we get negative 3x plus 11. Or you could write 11 minus 3x. Any questions about number 1?
No.
Number 2, if your teacher taught you to square the first one, double the product, and square the last one, you go straight to the answer. If you did not, then you wrote it down twice, and you distributed, and you got the same thing. So we would get 4x squared minus 6x minus 6x, and then plus 9. Yeah, because every time you double this, there's 2 of them. So you get 4x squared minus 12x minus 9. Number 3 should look familiar to some of you. Why? It was on your test. All right. So there was a question similar to this on every test, but because it's x to the 4th, we're going x squared and x squared. What can you multiply to get positive 100 that you can add to get negative 29? Negative 25 and negative 4. This is a difference of squares, and this is a difference of squares, so it factors to x plus 5 times x minus 5, and then x plus 2 times x minus 2. And that is today's warm-up. You should have 2 left on that sheet.
Yes.
Awesome. After those 2, we will turn them in. You'll earn your first 10 points for warm-ups. Okay, today's lesson. All right. Today we're going to revisit division. Now, we have 2 guys. You're being recorded right now. There are 2 methods for division. There's long division of polynomials, and there is synthetic division of polynomials. With the long division, I'm going to show it to you, but we're not going to be using that division in here. It's not terribly hard. I want you to see it, but when it comes to assessment, you're not responsible for long division. But let's go back to what we do know about long division from elementary school. In elementary, you learned how to take your dividend. Let's say we had 728. Dividend is the number we divide into. And our divisor of, let's say, 31. And if we did 728 divided by 31, this was the process that you did. You either looked at the 31 and the 72, or you looked at the 3 and the 7, and you said probably 2 times. And then 2 times the 31 is 62, and then that leaves us 10, and then we would bring down the 8. Okay? So since you guys aren't responsible for this part, you can just watch. You don't have to take notes right here. And then we would do the same thing. We would say 31 and 108, or we would look at the 3 and the 10, and we'd say, I think that goes in there 3 times. And then we'd do 3 times the 31, and we'd get 93, and we would subtract. So this would have a remainder of 15. Now when you first started learning how to divide, you would write 23R 15. And then you got a little more advanced, and you would say 23 and 15 31st. Do you remember that? Okay, you did that.
We were smart.
Yeah, you were smart back then. Oh, yeah.
We just got dumber each year.
No, what happens is, for all of us, if we don't use a skill that we've learned, we lose what we've learned. Every single one of us. So, for me now, calculus is challenging because I haven't done it since I graduated from grad school in 1996. Now, it used to be easy and fun. And now, it's something that I would have to study before I did. So, I did. Between 1996 and 2018 has been longer than you guys have done long division, but that's what it was, and that's what you did, and now you pull out your phone or a calculator to do it. I get that. So that's why we revisited it. All right, let's take a look at the next one. All right, so the next one is still division, but it's division of polynomials. And when we have division of polynomials, what we have to do is divide the same way. We're going to take our dividend and we're going to put it under. And then we take our divisor and it goes out here. And we go through the same process. If I took the x squared and divide it by the x, I get x. X squared divided by x is x. And then I would do the same thing I did over here. Here I did 2 times the 31. Now I'm going to do x times the x plus 2. And over here I subtracted, so over here let's subtract now. And when I do, the result is always going to eliminate that highest degree and leave me with the next lower one. And so then I would bring down, just like I brought down over here, the 8, I'm going to bring down the 10. And then I would say, okay, x goes into 5x how many times? 5. Okay, so we'd say 5. A positive 5. And if we multiply positive 5 times that x plus 2, we get 5x plus 10. And then we subtract, like we know to do with log division. We're left with nothing. Nothing means there's no remainder. So when I take x squared plus 7x plus 10 and divide by x plus 2, the result, also known as the quotient, is x plus 5. Now, we probably already knew that was going to happen. Because when we look at what we studied from factoring, x squared plus 7x plus 10, what can I multiply to get 10 that I can add to get 7? 5 and 2. Well, we divided by x plus 2, and we were left with x plus 5. Do you see they were both factors?
So you're factor it even.
Okay, so if we have something and we get a remainder of 0, that's going to tell us, and we're going to look at this over and over again, a remainder of 0 tells you that your divisor was a factor to start with, whether or not you recognize that. Yes, ma'am?
Are we going to have to divide like this at all?
No. No. Okay, so this is long division. This is an example of long division. Now, long division is the only way to do some polynomial division. That's not what I'm going to ask you to do right now. This is leading us into finding all the roots of a polynomial function. And so we don't need to do long division, but we do need to be proficient with synthetic division, which is what we're going to look at. So with synthetic division, you really only want to do it if your divisor is a linear. This means just x to the first power. Linear binomial with a leading coefficient of 1. That is the best time to use synthetic. But on some of the problems we do today, they're not going to be linear. They're going to be quadratic. And I'm going to show you how to handle that when I give you a quadratic.
Yes. Thank you.
You're welcome. Yeah, that's how I originally had it. When you create a slide, like I try to create the slide the day before so it'll go well, and you click and you set everything you want it and you tell it to save, when you open it back up, it doesn't open up any of your preferences. You kind of have to start it. It's awesome. Alright, so synthetic division. What do we do? It is a process that works the same over and over and over again. So we're going to practice this new skill. It's pretty simple, but we just have to practice it over and over until we've got it. Okay, same problem, guys. Same problem. So we know what the answer is. The answer is x plus 5. We just did it. So this is how it's going to look with synthetic division. Okay, with synthetic, you're always going to take your divisor and pretend like it's a factor, whether it is or not. And if that is your, if this was a factor, what would be the root?
-2. 0.
What would make this equal 0? Yeah. -2. So if this is our divisor, we're going to act like it's a root and give us the -2. It's what makes that divisor equal to 0 every time. Okay, so We call this a table. I don't know why. It looks like a backwards L. So you put the -2 on a backwards L. And then what we do is we take all of our coefficients, our understood 1 right here, the 7, and the 10. And we write down the coefficients and the constant. All right, now, this process is the same no matter what we're dividing synthetically. Every single time we bring down the first term. Every time you bring down the first one. So in this case, we're bringing down a 1. And then what we'll do is we'll take what's on the table and multiply it times that 1 that we just brought down. -2 times 1 is -2. And then we're going to add. So 7 plus -2 is 5. And then we're going to multiply. -2 times 5, -10. And then we're going to add 0. All right. This last one, every time, is your remainder. When we synthetically divide, that last number we get, every time is our remainder, which tells me there's no remainder. And if there's no remainder, once again, it verifies that this was a factor of our dividend. No remainder tells us the divisor is a factor. Now, that doesn't look like x plus 5, but I see a 5. So, when we look at this, and we're trying to get the expression that goes with it, this is always your constant. Don't do anything with it. That's your constant. This, the next one, is your x. If we had another one, it would be an x squared. If we had another one, it would be our x cubed. So we start with a plain old number after we do the remainder. Then we have the constant, our x squared, x cubed. There aren't any here, so we don't have these. We just have 1x plus 5. Our answer is x plus 5. Now, is that exactly what we got when we did long division? It's exactly what we got when we factored. They all tie in together. This was just quicker and easier. And it's pretty, I like how organized it is. Okay, so let's do another one. Oops, hold on. The other one's down lower. That's where it is. Okay, so we're going to do another one. So this one, our dividend has more terms. So it's to the third power. But the process, no matter what the problem, the process of synthetically dividing is the same. Okay, so here we have 2x cubed minus 3x squared minus 10x plus 7, all divided by x minus 3. So same process. We will start by saying to ourselves, if the divisor were a factor, what would the root be? 3. And that's what goes on the table. Then we pick off, in order, all of our coefficients and end with our constant. Okay? Then every time we bring down the first coefficient, no matter what it is, this time it's a 2. And then we multiply. 3 times 2 is 6. And then we add. -3 plus 6 is 3. And then we multiply. 3 times 3 is 9. And then we add. -1. And then we multiply. 3 times -1 is -3. And then we add. Okay, remember that last one is always your remainder. So this one has a remainder. It is not 0. Because it has a remainder, we know that x minus 3 actually is not a factor. if x minus 3 were a factor, that remainder would be 0. Okay? So now we got to deal with writing our answer. Okay, so we know that when we start right here, this is our constant, this is our x, this is our x squared. So we know that part of our answer. 2x squared plus 3x minus 1. Now we can't just ignore the remainder. So just like when we took the remainder and put it over the divisor when we did long division of numbers, we do the same thing when we have polynomial division. We take the remainder and put it over the divisor. So if there is a remainder, the remainder must go over the divisor. So this is our answer. Okay, same process every time. All right, I'm ready for you to try one. Are you ready to try one?
Yep.
Good. All right, let's do it. There it is. You try this one. Okay, so when I was walking around, it looked good. On the table, we put -2, and then we have 1, 5, 2, -8. We always bring down the first one, and then we multiply what's on the table times that. -2 times 1 is -2, and then we add. And then we start over again. Multiply. -2 times 3. And then we add. So really, we're multiplying. Then we add. Multiply, add. So let's do it again. Multiply, add. Now, that last one is our remainder. Our remainder is 0, which tells us that this divisor is a factor of the dividend. So if we factored this completely, that would be one of our factors. Okay, now, another factor would be when I plug in the x's. Okay, so what does it leave us? It leaves us x squared plus 3x minus 4. And several of you noticed that that factors again. That's really important for what we're going to do later. Right now, you don't have to. You do your division, you put in your x's, that's your answer. But those of you that notice that this factored again, that's taking us to the next step where we're headed next week. Okay. So, this is number 5 on your homework. Your homework tonight is the odds on the worksheet you picked up when you came in. So you can just write this in your notes if you want to. But you have to have this one done. Now, you're going to notice the divisor is not a linear binomial with a leading coefficient of 1. It is a quadratic. But you may have already spotted that that quadratic will factor. Okay? So that's what we need to do to use synthetic division here. In order to synthetically divide, we would have to take our divisor and factor it. What are the two factors of x squared plus 4x plus 3?
3.
Very good. It gives us x plus 3 and x plus 1. Those are the two factors. See, we're going to synthetically divide, but because we have two factors, we have to synthetically divide twice. Yes. Okay, so it doesn't matter which one we start with. Would you like to start with the -3 or the -1? -3. All right, so 1, 3, -1, -3. Same process. Bring down the first one. multiply, add, multiply, add, multiply, add. Okay, so we got a remainder of 0. That's good stuff. So since we got a remainder of 0, we can kind of ignore that part. And now we're going to do our second synthetic division. When you have to synthetically divide more than once, you always start with the answer from the one you just did. Don't start over. That won't get you anywhere. So we always start with our current answer. We're right here. We keep going. We just do it one more time. So you bring down the first one. You multiply, you add. You multiply, you add. Yeah, we got a 0 again. That's good news, because that means there's no remainder, which tells me that both x plus 3 and x plus 1 are factors, because I got no remainder, no remainder. Now, what is left, though, this is your constant, that's your variable. What's left is x minus 1, and that is the quotient. That is the answer to the division problem. What is left on that bottom line? Okay, so that's number 5. If you wrote that down, number 5 is done. Now, the last one we're going to do together is another one of your problems on synthetic division. Then we're going to talk about one more little thing. This one, number 15. Number 15 is missing a degree. If you look on your sheet with your homework problems, number 15 goes from x cubed to x squared, but it's missing the x to the first power. Whenever it's missing any of the degrees, you must put in a 0, or synthetic division doesn't work. So to set up this problem, the -3 would go there, the 1 would go here, the 5 would go there, but because I'm missing the plane on x, a 0 goes next to represent that linear term. And then finally, -18 is my constant. So anytime you're missing a degree, sometimes you might be missing several degrees. Like if I gave you one like this, x cubed minus 8, we were dividing into that, we would have a 1 for the cube, there's no squared, there's no plane on x, and then -8. Do you see how that works? Okay. All right, so now we can actually do this problem. So we bring down the 1, and we get 1, and then we multiply, and then we add, and then we multiply, and then we add, and then we multiply. I really like it when there's no remainder, because that means a lot of good stuff. It means I can do a lot with it. So this one has no remainder. So now I'll go back in and plug in. This would be an x. This would be an x squared. So my answer is x squared plus 2x minus 6. That is the answer to that division problem. Make sense? Good. Good. All right. Now, speaking of this no remainder telling us it's a factor, there's another way we can discover that. And to do that, I'm going to tie it back into our very first problem. This was our first problem, x squared plus 7x plus 10. We divided it by x plus 2, and we got out x plus 5. A really cool thing happens if you plug in the root into an expression. So if I said this is p of x, just named it some random function name, instead of f of x, I said p of x, and I evaluate this function for what we know is true. I know -2 is a root, don't I? Because I've already factored it. I've already divided it. When I plug in -2, let's see what I get out. This is 4. Whoops, let's make it look like a 4. Minus 14 plus 10. What is that? 0. I got 0 again.
This is right.
That gives me the remainder. If I plug in a value, it gives me the remainder if I synthetically divide. Pretty cool. And just to prove it, let's do negative 5. If we did negative 5, this gives me 25 minus 35 plus 10. What is that? 0. We know the remainder is 0 because we know those are two factors. Now, is the remainder always 0? No. Let's do P of 3. 3 squared plus 7 times 3 plus 10 is 9 plus 21 plus 10, 40. Did I get out 0? No. So, is 3 a root? No. All right. So, if x is a root, then when you plug in x, you get out 0. So, if you get out 0, it's a root. If you get out anything else, 1, 3, negative 2, anything else, not a root. Okay? So, your homework is 1 through 23 odd. We've already done 2 of them. Okay? If you use your class time wisely, you will be done when the bell rings. You may not pack up early unless I see completed work.